a little bit more of 5-2. So this won't be in your notes or anything, so you'll need to just get out another sheet of paper or use the back of something or something. We're going to start 5-3 here in just a little bit, but first we're going to practice a little bit more. Okay, all right, so I'm just going to randomly pick some problems off of this extra practice sheet that I had given you. I'll just randomly pick some. Hopefully I'm picking ones we haven't already done. Let's try this one. Remember, if you don't like the thetas, you can change that to x. It's perfectly okay to change them to x's if you want to. Now, this is a little bit different than some of the other ones we looked at because there is no side that's harder than the other side. They're about the same. So you really don't know where to start. I mean, there's no clear-cut way to start, and that's okay. You just have to pick a side and jump in and do it. What I do want you to notice is you have at least the potential here of using one of these special identities that you are committing to memory. Remember on your colored sheet, these first 8 need to be committed to memory. Hopefully they already are, but if they're not, you need to get them there real quick. So, one of the ones in that 8 that you have to memorize, I'll put it over here, says 1 plus tangent squared is secant squared. So I could change my secants into 1 plus tangent squareds. And that would be a smart move, wouldn't it? Because I want to end up with tangents over here. So I'm going to go ahead and change my secants into tangents using this identity that's right off my colored sheet. This is one of the Pythagorean identities. Now be really careful. You've got to think about secant to the 4th. I'm going to come over here a little bit so I have some room. You're going to think about that secant to the 4th as secant squared squared. That's how you got to think of it. This identity does not apply to 4th degree. You can't just make those fourths. That's not how it works. That identity and the other Pythagorean identities only work when the functions are squared. So I'm going to think of this secant to the 4th as secant squared squared. And then I can substitute 1 plus tangent squared in for the secant squared. So since 1 plus tangent squared is secant squared, I'll substitute that in. So now I have 1 plus tangent squared squared minus another 1 plus tangent squared. All right, is everybody with me up to this point? Changing the secant squareds into 1 plus tangent squared. Well, now at least I have the function I wanted. Now I just need to clean this up. So remember, this is a FOIL. This is a FOIL. Do not distribute the 2. This has to be FOILed. And I'm going to go ahead and distribute that negative on that last parentheses. All right, so here we go. Let's FOIL. First times first. Outsides and insides are going to give me 2 tan squareds. And last times last is going to give me tangent to the 4th. So this is what I get when I FOIL. That's the other part that's on the end. Hopefully, that's going to reduce to tangent to the fourth minus tangent squared. Does it? Let's see, the ones cancel. I've got a tangent to the fourth, right there. And 2 tan squared minus tan squared is plus tan squared. So there you go. Oh shoot, it's supposed to be a minus. Oh no, it's not, it's a plus. I copied it wrong. It's a plus. So there we go, we did it. Anybody have a question about that? That wasn't so bad once we got started. All right, let's pick one more off of here. Let's see.
Wait, Miss Ford, so you're just equaling them to each other? You're not canceling anything out?
My job is to change one side into the other side. So one side just stays the same. The other side has to get somehow reduced down to equal it. Let's try this one. This one looks like it might be a bit of a challenge. Okay. All right, how about this? Sine squared plus sine squared cosine squared plus cosine to the fourth equals 1. Let's make sure I copied it right. Okay. All right, somebody give me an idea. Obviously, all that stuff's got to go away, and you got to end up with just 1. So what might be a good plan?
Would you get the cosines on the same side and the sines on another side?
Okay, so let me say this one more time. There's a brick wall right here. Nothing moves across that brick wall. This side is going to stay 1. We aren't going to change that side. So everything we do is on that side of the equation. Okay? Those are the rules of the game. We don't do anything to both sides. You don't add things over, you don't do anything. There's a wall there that you cannot cross. So you either do all your work on this side of the wall or you do all your work on this side of the wall. Obviously I can't do very much with 1, so I'm going to work over here and try to make this ultimately equal 1.
Can you make cosine squared and squared, like in a parentheses squared?
Absolutely. Very good, Grace. So here's what I think, this is where Grace is going. She says, look, all that's got to cancel out. I got to be left with 1. So it sort of makes sense that if I change everything into the same function, I will have a better chance of getting everything to cancel. Would you agree with that strategy? So it doesn't matter which way we go. I might change my sines into cosines. And let's see what happens. What do I know about sine squared? What does sine squared equal? Sine squared equals?
Minus cosine.
Perfect, perfect. So I'm going to change that guy right there into 1 minus cosine squared. Then I'm going to do the same thing with this one. I'm going to change this one into 1 minus cosine squared, but he's times another cosine squared. And then I have my cosine to the fourth. Now, I chose to change everything into cosines. Could we have done the same thing, changing everything into sines? Yep. that would have been cosine squared squared, so that would have been 1 minus sine squared squared, and I would have had to FOIL. That's why I decided to go this way. All right, well, let's see what we've got. We've got 1 minus cosine squared. Now, this is a distribute, so it's going to be plus cosine squared minus cosine to the 4th, and then plus my cosine to the 4th. Well, what happens, guys? Is it what we wanted to have happen? Yep, because these cancel, and these cancel, and the only thing left is 1, which is exactly what we wanted to have left. So great strategy, absolutely wonderful. Get it all changed into the same function so that it can cancel out and leave you with what you wanted. All right, we'll do one more and then we got to move on. So let me see if I can find something here that looks interesting. Over on the back side. Okay, so secant over tangent plus cotangent equals sine. Now, there's nothing squared in here, at least right now. So I don't think I'm looking at my Pythagorean identities. I think I'm looking at the other ones. Since I want to rewrite this or end up here with sine, what might I do to all of these functions right here? Well, what's secant? Secant is 1 over cosine. That's the definition of secant. You need to know that. That's one of the things you have to memorize. You should already know that. What's tangent?
Sine over cosine.
Yep. And what is cotangent?
Cosine over cosine.
Well, we're going to change it into cosine over sine. We talked about that before. Very rarely is it productive to change a tangent into a cotangent. It can be on occasion, but not when you want to end up with sine. When you want to end up with sine, let's change it into cosine over sine. Now, this is a little bit more complicated than the other fractions we looked at because of this plus sign right here. You cannot invert and multiply until you add these two together. All right? So I'm going to show you another strategy. I think we talked about this earlier in the year, but I really don't want to rewrite all that stuff. It takes a long time and a lot of space. So instead what I'm going to do is look at all of these individual fractions. There are 3 individual fractions in this big improper, or in this big complex fraction. What would the common denominator be for these individual fractions? If you were going to get a common denominator for all of these purple circles, what would it be?
Cosine sine.
So I'm going to multiply each of my purple circles by cosine sine. That's going to take care of the complex fraction, so I won't have to get a common denominator and then invert and multiply. I'm just going to clear out all the denominators right now. Because you see, if I multiply this 1 over cosine by cosine sine, aren't these going to cancel? And that's going to leave me with just sine on the top. All right, now what happens on the bottom? Well, this cancels with this, so my first purple circle will be sine squared. And my second purple circle will be Cosine squared? Well, wait a minute. What's sine squared plus cosine squared?
1.
1. So I end up with sine over 1, which is just sine, which is what I wanted.
I have a question.
Yep.
So when you're trying to make the denominators the same, don't you just have to multiply cosine by sine? So like you multiply the bottom by sine and then 1 by sine. You don't have to like multiply by cosine again. Otherwise, the denominator would be something different.
Okay, now I am clearing all the denominators. All right. I am not getting a common denominator and adding. That is not what I'm doing. I'm clearing all the denominators. So I multiplied every single term by cosine sine. It's perfectly legal to multiply every term by whatever you want as long as you're multiplying by the same thing. That cleared the denominators. So I don't need to get a common denominator to add these anymore. If you want to do that, that will absolutely work. It's going to take longer and more space, and I didn't want to do it. But you absolutely can. You can get a common denominator here, and then invert and multiply, and you will end up with exactly the same result. Okay? All right. Okay, so we're moving on now in our notes to section 5.3. Now, we are kind of having to abbreviate this a little bit, so you are not going to be responsible for memorizing the what are called the sum and difference identities. The sum and difference identities, if you're looking at your colored sheet, you might want to label them. They are the ones over here on the, let's see, that would be the right column. And see how the top one says sine u plus v? That's a sum. And then right under it is u minus v. That's a difference. So you've got 2 of them for sine, 2 of them for cosine, and 2 of them for tangent. You are responsible for knowing how to use those, but you do not have to memorize them. When it comes time for a quiz over this or a quest, you'll have a note card that you will be allowed to write those identities down on. You will not be allowed to write down the 8 that I've already asked you to memorize, and then there's a couple more that you're going to have to memorize. But you do not have to memorize what we call the sum and difference identities. But let's see how they work. It says find the exact value of the sine of 15 degrees. Now, 15 is not one of our special angles. Would you agree with me? Yep. What are our special angles? Reed, turn your camera on, please. What are our special angles?
30, 60, 45.
Bingo. 15 is not among that. However, 15 can be written as, for example, the sine of 45 minus 30. Now, there are other ways to write it. I'm not saying this is the only way. But would you agree that 45 minus 30 is 15? Yeah. Now, I'm not picking random angles here. I didn't pick, 50 and 35 or something weird. I picked my special angles. And my job is to find a combination of those that gives me the angle I need. So one combination is 45 minus 30. Now, if you look on your sheet, we're going to use the formula. That's the sine of, is it u minus v? Yep, u minus v. So your u is 45 and your v is 30. So according to the formula, we take the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. Now, look at that formula for the sine of u minus v and see if does that make sense to you, what I did there. I let my U be 45 and my V be 30. So now I have to plug in these four numbers. I have to plug in the sine of 45 and the cosine of 30 and the cosine of 45 and the sine of 30. So what I like to do when I'm doing a whole bunch of these, I like to, over to the side or somewhere, draw my 45-degree triangle. And in this case, my 30. Can't forget that stuff. That will not be on your note card. That's supposed to already be memorized. But then you can just refer to this when you plug in your numbers. So the sine of 45 would be 1 over root 2, or root 2 over 2. The cosine of 30 is root 3 over 2. The cosine of 45 is also root 2 over 2. And the sine of 30 is 1/2. So that's all old news. But you got to remember it because you're going to be using those numbers over and over and over again in these problems. So now these two are multiplied. So top times top, bottom times bottom, that's root 6 over 4. Top times top, bottom times bottom, root 2 over 4. These do not combine. However, they do have the same denominator, so we usually write it as one fraction instead of 2. So root 6 minus root 2 over 4. All right, these problems take up so much space, I'm going to have to erase all that and start over. Does anybody have a question about any of that stuff before I erase it all? All right, let's look at the next one, the cosine of 165. Now, something to think about is this. Our special triangles, our special angles are exactly what Grace said, 30, 45, and 60. However, the 30, the 45, and the 60 can happen in the other quadrants. Remember that? An angle of 150, for example, is itself special because it creates a 30-degree reference angle. So we're not tied to just 45, 30, and 60. We can use those angles in every quadrant. So I might need to do that with the cosine of 165 because 165 is pretty big. I'll give you a hint. When I do this, if the number ends in 5, I always start with a 45. So 165 would be 45 plus 120. Is 120 special, though? Can I use 120? Think about it now. What's the reference angle for 120? What's this angle for 120?
60.
Absolutely. And if it's 60, then I can use it. But like before, what do I have to remember if I'm going to use 120? I'm going to have a negative over here, right? All right, here we go. This is a cosine and it's a sum. U plus V. Is that right? U plus V. All right, so what's the formula say? Cosine of the first, cosine of the second, minus sine of the first, sine of the second. So I just found the formula on my sheet that was for the cosine of an angle plus an angle. I let my U be 45 and my V be 120, and there it is. Anybody have a question about that? Okay. So let's start plugging in the numbers. Again, there's 4 of them. You got to plug in. The cosine and sine of 45, remember, are the same. And they're 1 over root 2 or root 2 over 2. Now, use that one a lot, so you'll probably just start rattling that off. The cosine and sine are root 2 over 2 of 45. Now, what about 120? Well, I drew 120. I got my 60 reference angle. Across from the 60 is root 3. I labeled the sides, put the negative on. So the cosine is negative 1/2. And the sine is root 3 over 2. So multiplying each pair, because that's what these formulas do, they multiply each pair. We have negative root 2 over 4 minus root 6 over 4. So this time we have negative root 2 minus root 6 over 4. Does that look similar to the answer we got for the last problem? Yeah. Does it make sense that it would look similar? Yeah, because the only angles we're using are the 30, 45, and 60, right? And that means the only numbers that are going to show up in here are 1s, 2s, root 3s, and root 2s. That's it. Those are the only options we're going to have over here. So we're usually going to get some combination of that. All right, anybody have a question about that one? All right, one more, or 2 more, I guess. Let's do the tangent of 195. How do you want to write 195? And I want to emphasize there are lots of ways to write it. To me, there's like an obvious way, but there are tons of ways that you could write 195. So what are you thinking?
$45 plus 150.
That's what I'm thinking. Anytime it ends in 5, I'm thinking 45. And 150 is special. We already talked about that because 150 has a 30-degree reference angle. So this is 1, this is 2, and this is root 3 negative. So there's a picture of my 150. And here's my 45. Now, this is the formula for the tangent of u plus v. So that formula says tangent of the first plus tangent of the second over 1 minus tan of the first, tan of the second. So tan u plus tan v over 1 minus tan u tan v. All right, let's start plugging in numbers. Now we're plugging in tangents now. So what's a tangent of 45?
One.
Yeah, our favorite. We love the tangent of 45. It's 1. What about the tangent of 150? Up here, what's the tangent of 150?
Negative root 3 over negative 3?
Well, there's only one negative. So it'd be negative, yeah, so it's negative root 3 over 3. Because it's 1 over negative root 3. So there's one negative, you can put it in the top of the denominator. It's just going to turn this into a subtraction. Over 1 minus 1 times negative root 3 over 3. Same 2 numbers are in the denominator. They're just being multiplied. These are a little bit more difficult to mess with. So we got 1 minus root 3 over 3 over 1 plus root 3 over 3. Is that right? Do not cancel. This prevents you from canceling. You can't just take out a piece. You have to take the whole thing or nothing at all. So nothing cancels. We sort of have the same mess we had a while ago, though, with these fractions within a bigger fraction. This is called a complex fraction. What is the common denominator of each piece of that big complex fraction? What would be the common denominator for the whole shebang? Well, this denominator's 1, this one's 3, this one's 1, this one's 3. What's the common denominator between 1 and 3?
3.
Yep, so I'm going to multiply everything by 3. And what's going to happen when I do that? When I multiply everything by 3, I'm going to end up with 3 minus root 3 over 3 plus root 3. Now, still nothing cancels, but at least I don't have those fractions in there anymore. Who remembers how to simplify this? Algebra 2, all over again. How do we simplify something like that?
Multiply by the conjugate.
Love it. We're doing spoken math language. Awesome, awesome, awesome. We're going to multiply top and bottom by 3 minus root 3. We always multiply by the conjugate of the denominator. So since that's my denominator, this will be the conjugate. And now I'll just start foiling away. So on the top, I'm going to get 9 minus 3 root 3, 3 root 3, and then remember, when you multiply two negatives, you're going to get positive, and when you multiply root 3 times root 3, you just get 3. And on the bottom, same thing. I'm foiling. All right, anybody notice anything that's happening now? Can I do any simplifying on the top?
Yeah, you just cancel out a negative 3 root 3 plus 3 root 3.
Well, down the bottom, yeah, on the bottom you can sure cancel those out. And you're left with 6 on the bottom, 9 minus 3. On the top they don't cancel though. What happens on the top?
Combine them.
Yep, so we have 12 minus 6 root 3. What do you notice about all 3 parts of that fraction?
Is it divisible by 3?
6.
By 6, yep, we can pull a 6 out. So that's going to leave us with 2 minus root 3 over 1, or just 2 minus root 3. So the answer to the problem is 2 minus root 3. There's a lot of arithmetic in that problem. Not very much trigonometry, but a lot of arithmetic. Just for fun, pull your calculator out if you have it handy and type in the tangent of 195. You need to be set in degrees. Type in the tangent of 195 and then type 2 minus root 3. And guess what happens? They're the same because this is the tangent of 195. This is the exact tangent of 195. No round off error in that. That is it exactly. All right, we're going to do one more of these. This one is a cosecant. Now, when you look at your identity sheet, do you have a formula for the cosecant of 2 angles added together or subtracted? No. I'll just tell you, you don't. You have 1 for cosine, 1 for sine, or you have 2 for cosine, 2 for sine, 2 for tangent. 1 add and 1 subtract. So, what I would suggest that you do is pretend for a moment that this is the sine of negative 255, because that you have a formula for. And then once you work through it and you get your answer, since that answer will be the sine, what will you have to do to end up with the cosecant? You'll just take your answer and reciprocal it? Yep, that's right. So we're not going to get a bunch more formulas. We're just going to pretend this is a sine problem and then remind ourselves that we have to flip it at the end. Okay, so here we go. You need to come up with a way of getting negative 255 from your special angles. Anybody have a thought on that?
A negative 45 minus 210.
That sounds like a winner to me. That'll do it. That'll do it. Remember, you can use negative angles as long as they are special. We don't want to be using, negative 62 or something like that. But as long as they're special, you can use positives and negatives. Doesn't matter. So here's my formula. This is u minus v. So that's going to be the sine of negative 45 times the cosine of 210 minus the cosine of negative 45 times the sine of 210. Sine u cosine v minus cosine u sine v.
Is the 210 negative or positive?
Well, I made this a subtraction problem, so I'm using my u minus v formula, so 210 is v.
Oh, okay.
Now, if you want to make this plus a negative, then of course you're using your u plus v formula, and they're both negative. That is not what I did. I did it as a minus, because that's what he said. It can go either way. But if I'm using my subtraction formula, then that's a positive 210. Because I'm subtracting 210. I don't have either one of those over here, so I'm going to go ahead and erase these and draw my negative 45 and my 210. So negative 45 would be down here like this. Don't forget, you got a negative on that one. And then 210 would be all the way over here. And how big will my reference angle be if this is 210? If this angle is 210, then that reference angle is how big?
$60.
Oh my gosh. Okay, guys. I'm going to put my fingers on the two lines that make those angles. This is 180, this is 210. What is the angle between 180 and 210?
30 degrees.
Yeah, that's 30. If you miss your reference angle, you're going to miss your problem. And you can't miss your reference angle. You just got to stop and think about it for a minute. Don't take guesses. You say you think it's 60. If you take 180 and go 60 more, do you end up at 210? No. Check your answers. Don't just guess. So that's a 30. So we have 1, 2, root 3. They're both negative because that's in quadrant 3. Now I'm going to do something here a little different than I normally do. I'm not going to rationalize because I know what's going to happen eventually, right? Well, actually, never mind. I'm going to go ahead and rationalize. So the sign of negative 45 would be negative root 2 over 2. The cosine of 210 is negative root 3 over 2. The cosine is 1 root 2 over 2. And the sine is negative 1/2. So when I do my arithmetic arithmetic, this is the answer we keep getting when we did those other ones. We get root 6 plus root 2 over 4. Positive root 6 over 4, and then minus a negative root 2 over 4. This is the sign. So now I got to turn it over, and that will be the cosecant. But now I get to rationalize it. So I'll multiply the top and bottom like I did a minute ago by the conjugate. And something really cool is going to happen on the bottom. What does your bottom equal? When you multiply all this out, what are you going to end up with down there? Six minus 2. You end up with 4 on the bottom. So what happens is it's going to cancel out the 4 on the top, and the answer to the problem is just root 6 minus root 2. This is just a FOIL, but when you FOIL it out, you just get 6 minus 2, so you get 4. And that is the cosecant. Now, the next set of problems, I got to make sure we're clear on what the directions mean. When you look at problem 2a, sine 58 cosine 32 minus sine 32 cosine 58, what formula or identity on your colored sheet does that remind you of? The numbers are already plugged in it. What formula does that look like? It's sine cosine minus sine cosine. What formula is that?
Sine u minus v.
Yep, it's the formula for the sine of u minus v. That is exactly right. What is the u and v in this problem? This is the formula for the sine of u minus v, but our u is 58, and our v is 32, right? So that right there is an expanded formula for the sine of 26. Now, I don't know what the sine of 26 is, but would you agree that that formula is the sine of 26? Yep. All right, look at the next one. D. Oh, it kind of went off the page. Sine 6, sine 10, minus cosine 6, cosine 10. This one's a tricky one. Which one does it match up with?
Is it cosine u minus v?
It is the cosine of u minus v, except what? Actually, it's not. It's the cosine of u plus v, isn't it? Isn't it the cosine of u plus v?
Yeah.
Yeah. So, what's my u and what's my v? So this is the formula for the cosine of 6 plus 10. So this is just the cosine of 16. These are backwards. Since they're backwards, it doesn't really matter because you're going to be adding these two numbers anyway. you know what? I think it is going to matter. I think it is going to matter because I need the cosine to be first. This is the actual formula that's written on the paper, isn't it? Isn't it cosine, cosine minus sine, sine? So I'm still going to be adding these together, but it's backwards, so I have to put a negative out in front. So the answer to that would be negative because, negative cosine 16, because the formula on the work or on the notes is backwards of the formula that you need. The identity on the colored sheet is cosine, cosine minus sine, sine. So we have to turn that around first by factoring out a negative. That'll turn it around. But that negative then has to show up in the answer. It's still the cosine of 16, but it's negative the cosine of 16. Because this is backwards. That was a little bit tricky. All right, what about B? Oh, sorry, I went out of order. That was D. What about B? Tan 13 plus tan 18. Which formula is this?
Tan U plus B.
Tangent U plus B, yep. So my U and my V are 13 and 18. So this is the formula for the tangent of 31. Cosine, cosine, minus sine, sine. Okay, we just talked about this one. Cosine, cosine, minus sine, sine is the formula for what?
Cosine U plus V.
Yep. So this is going to be U plus V. So this is a formula for the cosine of 21x. As long as you have your formulas right there in front of you, this is pretty easy. And you will have them. You will not need to memorize them. Okay, one more. Now I'm on E. Sorry about skipping around. That went off the page too, but it's sine 37 cosine 19 plus cosine 37 sine 19. What formula?
Sine U plus U plus
So
V.
it's sine, and it's U plus V, so that's 37 plus 19. So this is the formula for the sine of 56. Get through these next couple and then we'll have this section. Okay, so here's a verify, which is what we were practicing earlier in the period. And if you want to, you can change the pi over 2 to 90 if that's easier for you. You certainly can leave a pi over 2, but you can also change it to 90 if you want. Your job is to prove that this is true. So, do you have an idea on what you might do? Can you break this apart? What does your formula say about the sine of an angle minus an angle? What is this formula going to be? That's your U and your V.
Both cosine P minus cosine U sine sine V.
And I'm putting in the x and the 90, so it'll be sine x cosine 90 minus cosine x sine 90. Now there's not much I can do with sine x, But I can figure out the cosine of 90. 90 is on my circle right up here. This is 90, right here, pi over 2. The cosine of 90 is 0. And the sine of 90 is 1. Remember, cosine is x, sine is y. Since your radius is 1, you really don't have to worry about that. So x over r is 0, and y over r is 1. Well, look what happens. This is gone. Sine times 0 is gone. And here I just have negative cosine x, which is exactly what I was supposed to prove. I simplified this using my formula, and I ended up with exactly what I was supposed to. Cotangent 90 minus u equals tan u. All right, this one's a tough one. This one's tough.
Mrs. Ford,
Yep.
is the u and x, or is it a part of the equation as well? Like, can we change the u into an x, or does it just
Sure,
stay like
you can
u?
change it anything you want. It's like having an n in a regular old equation. You can make it whatever letter you want. So theta, x, p, j, whatever you want to make it, it's fine.
I just got confused for a second because I thought it may have been a part of the equation.
What am I going to do with the cotangent of 90 minus theta, or 90 minus u? I don't have a formula for that, do I?
Treat it like a tangent.
I can, and in fact, since the tangent formula on the sheet is a fraction, I think I'll just turn it over. So the formula for the tangent is, the regular tangent is tangent 90 minus tangent u over 1 plus tangent 90 tangent u. So I just wrote my formula upside down. Does that make sense to you? I went ahead and just flipped over the original since it was a fraction. So the cotangent will be that. But there's a huge problem with that, guys. Does anybody know what the problem is? What's the tangent of 90?
Undefined.
Yeah, this isn't gonna work. Can't do it. Can't do the tangent of 90. Shoot! Back to the drawing board. It was a good plan, but it doesn't work. What's another way of thinking about cotangent other than the reciprocal of the tangent?
Sine over cosine.
Actually, cosine over sine. So the cotangent could be cosine 90 minus u over sine 90 minus u. Remember, the cotangent of anything is the cosine of that thing divided by the sine of that thing. So now I have to use 2 of my formulas. So that will be cosine u minus v, or x minus y, or alpha minus beta, whatever. It's cosine of the first, cosine of the second, plus sine of the first, sine of the second. That's my cosine formula. And that's over sine of the first, cosine of the second, minus sine of the second, cosine of the first. Boy, that's a mess. We're almost done, guys. We're going to quit as soon as we're done with this problem. What do you think we need to do next? Well, can I plug in the cosine of 90 and the sine of 90? Can I plug these numbers in? What is the cosine of 90? Look up here. What's the cosine of 90?
1
Cosine is which letter?
x.
X.
Would be 0.
So it's 0 cosine u. Well, actually, I'm not even going to write that down, because if it's 0, that's just going to go away, because it's 0 times something, so it's 0. What's the sine of 90?
1.
So that's going to be 1 sine. That's 1. This one's 0. All right, so the sine of 90 is still 1, so that's a cosine. And the cosine of 90 is still 0, so that's gone. So when I stuck in my zeros for the cosine of 90, it took out some of this problem. And all I have left is sine over cosine. And what's sine over cosine? There we go. There we go. All right, well, it's time to go. I only have one more to do, so we'll finish that next time. So, I need a note here. And we'll be having a quiz over the simplification, not our next class, but our class after that. So please get those 8 things memorized, okay guys? So that you're ready to go. We'll practice again next time a few. And I did give you an extra practice sheet. It says verify the following. I gave you this a while back. So if you want to practice a few on your own, you can do that too. All right, have a great day. See ya.
Thank you.
Thank you.
Bye.